Okay, today we're going to be taking a look at thermocouple placement and also discussing the best ways to um, attach a thermocouple to an assembly board that you're getting ready to profile. And so really the biggest part about this um, is deciding what you want to measure on the board and why you want to measure that. And so um, first, as kind of an overview here, um, we need to discuss what's impactful or what's pertinent to measure when you're profiling. And so, of course, the main things that come to mind are the thermally sensitive components, um, components with a larger mass that eat up a lot of that temperature or take longer to heat up. Um, High density or clumped areas of components that diffuse temperature. If you have some really tightly placed components on a board, those are potential places to measure. And so um, other examples of individual components that we want to pay special attention to are LEDs, which have a max temperature rating as well as a time factor as far as how long they should be in a process. And along with LEDs, we want to pay attention to capacitors, whether it's aluminum, electrolytic, film, or tantalum, crystal oscillators and resonators, fuses, inductors, and transformers are always uh, potentially great things to profile or make sure that um, they're not being overheated. Any non-solid state relays, as well as connectors or switches. Connectors, the plastics relax if they're in the process for too long, which loosens the contacts inside the connector. And so it may not be something that's intuitive off the bat as an important thing to measure, but connectors can be very important as well. And so one thing we have here is standard that was put out by IPC, introduced at the end of 2008 with help from IBM and other companies, called J Standard 075. And that really designates thermally sensitive components that you might want to, or that they recommend profiling. And it also has some literature in there about parts packaging and labeling the components as thermally sensitive. And so it kind of denotes how to search for that on a component, and is worth taking a look at that standard, which is available. And so moving right along here, what we're going to want to look at once we've decided what to measure is the materials that we need for a good thermocouple placement and attachment to our assembly board. And you might be thinking, well, okay, I've just got a blank board here. Is that going to work as well as the product that I'm producing? And the answer is no, pretty much. If you want to profile, really the best way to get the most accurate profile is to have an extra assembly board of the product that you're producing for your customer. And so you may ask them, can we have an extra board that we can use for attaching thermocouples and get you the most accurate profiles, the most accurate measurements that you're wanting to verify and pay attention to. And so there's really no replacement for having an actual board with the components clumped in the exact same way that you're using them for production. And so along with the board and your thermocouples, there's a few different methods for placing thermocouples on an assembly board. Many people will say, just slap some Kapton tape over it and you're good to go. Make sure there's a little strain relief. But Kapton, it does have its benefits. It's easy to apply. It's quick. Um, you can see where the TC bead is through the Kapton tape, and so that's always nice. But it is a silicone adhesive, and really once those adhesives get up to reflow temperatures, they tend to separate or lose their sticking power, and you oftentimes end up with thermocouples that are um, come unattached from what you're trying to measure, or become intermittently in contact with what you're trying to measure, and don't always generate the most accurate um, profile as far as your spec limits are concerned. And so Kapton is a nice quick go-to if you need to do some quick profiling, or really just get something through right away. But I would say aluminum tape is probably a next step up from that. With aluminum tape, you can, it conforms around the TC bead really nicely, and so you don't get as many of the air pockets that you see with that can easily form with Kapton. Unfortunately, aluminum tape, you can't see through it, and so you don't know exactly where the TC bead is placed, although it does form nicely around it. And along with Kapton, aluminum tape is a silicone adhesive as well, and so it does run into problems as far as staying attached to the board or keeping your thermocouple bead exactly on what you're trying to measure, even if it doesn't come completely unattached. It does loosen and can allow for vibrating or other sorts of movement that is undesirable. And so really, as far as getting the most accurate measurement and knowing that it's the component that you place the TC on that you're profiling and reading on the computer from your downloaded profile, there's really no replacement for using some high temp solder and soldering the thermocouple bead onto the component that you're trying to measure, which is, of course, why it's important to have an actual board, an actual copy of the assembly you're producing, and so that you can get that genuine 100% measurement without any doubts about if the thermocouple bead shifted or if it became unattached to your component during the process. And so at ECD, we certainly recommend soldering the TC bead onto the board as the best option for getting accurate measurements and accurate results. And so with that, what we're going to want to do here when you're placing a TC onto the board, you'll want to first give it some strain relief a little bit, a few inches down the lead of the TC, and so that if it gets yanked by accident or if it tensions up in the oven, that it's not just going to easily be pulled right off of the solder joint. And so we don't want the solder joint to be the only strain relief for it. It's good to use some tack pack or some other high temp glue to hold down the leads of your TCs a few inches from the bead. And so with that, what you'll want to do, since the solder is really only going to want to wet or form around one side of that thermocouple, is to make the smallest bead possible, and we want to encapsulate the entire thermocouple bead in the solder. And so some good criteria for that is to make intimate contact with what you're soldering, and to try not to increase the mass enough that it affects a measurement. And some people ask, if my thermocouple bead is towards the top of my solder blob or my solder ball that's at my measuring point, where am I actually measuring temperature? And that's a great question. The best answer is that if you're using this method, you're already on the right track, because thermocouple with a solder joint around it, encapsulated in a solder bead, has excellent heat transfer, and it will basically be the direct result of what you're measuring. And even if your bead is towards the top of the solder blob, that's okay. I mean, we're in most instances we're talking about a couple hundredths of an inch, and so their thermal characteristics are virtually the same, whether it's at the top or the bottom or the side of the solder ball, as long as it's encapsulated in it. And really the main thing that you want to look out for or avoid when attaching TCs in this way is having the leads of the TC be crossed. The exposed leads where it's just metal on metal, you don't want those to cross, because then you're actually measuring temperature, in a half inch or an inch above the actual point you're trying to measure. And so that's what you want to try and avoid. And using good strain relief with tack pack or a little capped on tape a few inches down the lead of your thermocouple will go a long ways as far as protecting you from that error in measurement. And so with that, we can take a look at a couple trickier ones are the BGAs. For example, there are some different methods as far as measuring a BGA on the surface and applying an offset that's derived from the dimensions and the makeup of the BGA material, and getting a fairly close measurement results with those offsets that you apply in just measuring the top side of a BGA. But again, if you want the actual 100%, this is the measurement. You have to do the actual work alongside that. And what that involves with a BGA is to, in most instances, to drill into the back side of the board and place a thermocouple on the underside of a BGA in the hole that you drilled in the PCB, and backfill that with some SMT high temp epoxy. And so that way you're measuring exactly what you're trying to measure, and there's no way to confuse it, there's no way to mess up any math with an offset, and you get a 100% accurate reading that way. And so in conclusion, you definitely have some different options as far as what you choose to measure on your board. It's always good to measure across the width of the board on various components, as opposed to the length of the board, which may have very similar readings as it's traveling through an oven. But if you're measuring across the width, you can kind of you can get an idea if your oven's heating evenly, or if any changes need to be made as far as the recipe is concerned to meet your spec limits. And so with that, you'll have some options as far as what you measure. Reviewing the J Standard 075, I would highly encourage that, and as well as your placement options, the attachment methods. And so for a quick job, a quick profile, go for the Kapton or the aluminum tape if it's just a one-time profile that you need to get done. But to really get the best measurement results out of it and the most accurate profiles, it's really best just to solder the TC beads onto the boards. And so that will conclude our video on thermocouple placement and attachment.